Hello everyone. I hope you can hear me. Good morning all. I welcome you all to the Solid Edge informative webinar organized by the Manufacturing Engineering Association in collaboration with Siemens Digital Industries. So at first, let me introduce myself. I'm Kulani Jayaratna, a member of the Manufacturing Engineering Association, and I will be your moderator for today. As engineering design has become one of the mandatory pillars of the profession of engineering, it is obvious that you should be equipped with state-of-the-art tools to create your design to be a successful engineer in the field. That's why we organized this seminar, this webinar, to give you information on Solid Edge, a state-of-the-art design software. So without further ado, I would like to invite Mr. Pranit Maduranga, the Vice President of Manufacturing Engineering Association, to introduce you into this webinar's content and to commence this session. Mr. Pranit?
Yeah. Thank you, Kulani. I'm guessing I'm loud and clear. Can anyone confirm that?
Yes, we can hear you loud and clear.
Okay, thank you, Kulani. Hello and good morning to all of you. As human beings, we were always being innovative in our life. In the Stone Age, early men used stone tools to make their life easier. They had the requirement. They may have to think about the suitable materials and shape of the tool. After many testings and failings with various materials and shapes, they created a better tool. It can be considered as one of the earliest evidence of engineering. And on the same day which engineering was born, the designing was born too. So designing plays such a critical role in engineering. In 1961, Mr. Patrick Harandi created the first computer-aided or CAD system in collaborating with General Motors. That creation made a huge positive impact on both engineering and designing fields. Since then, CAD was rapidly developed while being the backbone of most of the current day engineering marvels. So in the present, designing turns out to be a profession. Furthermore, there is a high demand for engineers equipped with designing sense and skill. So if you are planning to awake the designer inside you, today is the best day to make the first move on it. And also, if you are already into CAD, this will be a life-changing opportunity as we are going to learn much more about new trends and technologies in CAD from the pioneers of the field. With that being said, I make this an opportunity to welcome all the participants here on behalf of the Manufacturing Engineering Association. As our honorable guest, Mr. Janaka Mangala, Senior Lecturer, University of Moratuwa, Director of the Die and Mold Facilitation Center, and the Secretary, Die and Mold Association of Sri Lanka. Sir, it's a great pleasure to have you here. I'm sure your experiences in both academic and industry will add a great value to this session. Then Mr. Ranidu Danthanarayana, Country Representative of Philips Corporation, we warmly welcome you to the event. Next, representing Panacea Group, Mr. Asita Punchiheva, CEO of the Panacea Group, Mr. Ashen D. Silva, Assistant Manager of the Technical Division, and also Mr. Samir Madapatha, Director of Engineering Solutions, and who always been cooperative with us to organize this event. We welcome you all to this session. And also we express our gratitude to the Panacea Group for working with us for many years. And we welcome all who participated in the event with a keen interest in engineering designing. So before commencing the session, let me give you a brief introduction to today's session. This session is for giving you a good idea about the engineering designing area, or you will learn about the evaluation and future trends of this field. You will learn what are the career opportunities and entrepreneurship opportunities related to this field. This session will allow you to clarify any related doubts. Manufacturing a design is the next step of the manufacturing process. In this session, our guest speakers will give you a good understanding of design to manufacture and manufacturability. Siemens Solid Edge is a well-known design software throughout the field as it introduces various easy-to-use features which makes designing easy and hassle-free. There will be an introduction to the software and you will have a basic understanding to use it in your projects. Siemens company provide a free student version of Solid Edge for all the university students. You will be able to get that privilege. And if you are planning to start an engineering designing startup, Siemens company has a great offer for you. So before handing over to Kulani, I invite all of you to actively participate in this event. Be interactive with the resource persons here and get the maximum out of this great opportunity. Thank you.
Thank you, Praneeth. Thank you, Praneeth. Subsequently, it's time to invite our first resource person for the day, Mr. Janaka Mangala, a senior lecturer at University of Moratuwa, who is a specialist in computer-aided design and modeling, the director of Die and Mold Facilitation Center, also the secretary of the Die and Mold Association in Sri Lanka. He will be speaking about engineering design and evolution. So I kindly invite Mr. Janaka Mangala to take the screen.
Good morning, everyone.
Good morning.
Can you all hear me?
Yes, we can hear you.
Bit of background noise, please bear with me. Anyway, thank you very much for all these kind words about me. I think it's not what is important. The important is the topics that we are going to discuss today. So let me share the screen first. I hope I am allowed to share.
Yes, you are, Mr. Janaka.
Can you all see my screen on your terminals?
Yes, we can see the screen.
Okay, very nice. You see the presentation or the speaker note?
We can see the presentation.
Right, okay, that's fine.
Both, sir. We can see both.
You can see both, right? Let me. Is it okay?
That's the presenter's view. Now, the main presentation is smaller.
Our main presentation is small. Okay, that is the. Let me change this.
This is the presenter's view.
Yeah, I need to switch the windows. Is it okay now?
Yeah, it's great. Now we can see the presentation full screen.
Right, okay, good. So the topics I was given is the engineering design and the design evolution. From the day that I got this one, I was wondering how I'm going to deliver the content within 20 minutes. And it has been happening ever since the humans was trying to make something on this earth. So I've been given only 20 minutes to describe everything. Anyway, let's start. So my topics today would be introduction, the brief introduction, and also the conventional design process. I'm not going to teach you the design, but only the process, and also the computer-aided design process, and the computer-aided analysis and the optimizations that we used along with our design, plus something else. So these are some of the words that I captured from the internet when I searched for design. So don't think that design belongs to only engineers or only the mechanical engineers or electrical or electronics engineers. Anybody who can come out with something to fulfill the requirements, we could say is designing something to meet the requirements. So it could be an art, it could be an advertisement, could be a newsletter or news article, could be a medicine, it could be anything. So, but anyway, our topic would be limited to the engineering field and then the tools and techniques that we're going to use for designing things that comes in our day-to-day life. A person whose job is to design or build machines, engines, and so on, we can call him an engineer. Could be a civil engineer, mechanical engineer, a software engineer, anybody who designs something using techniques, tools, and the scientific principles, then we call him a designer. The designer's job is huge. I mean, I can design something to suit my requirements, my beliefs, or my needs, or maybe my colleagues, or maybe my parents, my family members. But the designers will goes beyond that one. If you can design something that suits, I would say anybody, that is what the designer's job is today. Not to design something for your personal requirements. It is of course also a design, but your task goes beyond that one. A designer should have a good empathy, what others see, how others can think, how others feel before you enter into the design. It is true that we have different tools, software tools, hardware tools, and a lot of books written on design and everything. But remember, everything starts from your visualizations. If you can't visualize, I don't think that you can be a designer. You should not only visualize, you should be able to convert that one into something tangible with the help of a team. So the designer would not work alone, he will work with a team. And he's a specially trained person. So understand this one, specially trained to achieve something. The requirements of, I would say, a customer while meeting the design specifications, design standards, as well as the safety of the users. The last one, the safety, is of course very important. And nowadays, we even go beyond that one. We even think of the environment. At the end of the lifetime, how are we going to dispose the product? In the long run, will it affect the culture, the society, the religion, or anything? Early days, designer would have only a limited constraints, but today we have huge constraints to work around. So the challenge is to meet all these things and then come out with something which is economically feasible, affordable, and sustainable in the long run. So the task ahead of designer is huge, and day by day it is getting more and more complicated. So when you say design, it's not only like mechanical or electrical, it's all about the business, it's all about art, it's all about engineering, it's all about communication, it's everything. It's everything. So it's a mix. It's a mix. We can't say that it's a percentage wise, the contribution from the art is this much, the contribution from the mechanical engineering or the technical field is so much. So it's varying depending on the product that you're going to design. While browsing the internet, I was on this very interesting page or this image, some of the development in the Airbus industry. From 2010, I think maybe we have not heard about this thing. Right? We're talking about the fully electric 4-engine aerobatic aircraft. Who knows, maybe in future, right? Don't keep your hopes dead. We might be having a completely electrical aircraft. Who knows? The things will change. Everything depends on your ability to imagine something new and then convert it to something tangible. This is all what you need. If you are there to repeat somebody else's work by looking at a textbook or an article or a research paper, like what you do in the industry most of the time, doing the maintenance work, then there won't be any new designs coming out. You want to be crazy about this field. People will understand or label you as crazy when you initially mention something about a new product, new concept, new way of achieving something, that is what you need. If you can tolerate all these things and then just target on your destination, then definitely you can be a designer. Let's see the history. If we go back to our long ago, when we first start even thinking of an aircraft, and then the things that we have today, what you see is the complexity increases. The very early days, it was a very simple design by looking at today's point of view. But maybe then it was maybe a very complicated, even nobody could imagine. But today we can see we have achieved a lot. The development. This is engineering design. Not only in the aircraft industry, even in the other fields, you can see day by day the complexity increases. So what will happen tomorrow? Or what will happen day after tomorrow? Or what will happen in 10 years' time? If you can imagine something new, that means you are in the right path. If you constrain with what you have today, or if you want to be simple, always safe, then you are not in the right field. That always take the challenge. The designers are always taking challenges. Some of the pictures you can see, just to, wake up your mind, the complexity always increases. When you first develop the steam engine, do you think that the people lived at that time were thinking of a hybrid car or an hydrogen car? Never, never. Even today, after this, what will happen in the future? It's all up to you. If you can go in the right path, I can't tell you how to be an innovative. I can't tell you how to be a good design engineer, but I can give you the qualities that you need to improve on to become a good design engineer. You can see all these things increasing complexity. The convenience, the user convenience increases. The day by day, the things that we have to do from our mind is reduces. That is one of the bad points if you take it negatively. So, for example, the today's, especially the young generation, think that everything is in their mobile phone. You have it, of course. You can access the internet. You can access your cloud data. You can access almost any software tool. So, if you have the mobile phone with you, sometimes you might be thinking that, yes, I know everything and I can handle everything. But that the very critical part, the important part, your imagination is not there. You are visualizing somebody else's work. You are training your mind to be like observers, not as designers. And one day you might feel that without the mobile phone, you're totally failed or handicapped. It should not be the case. It's just a tool, like a computer or any other thing, it's just a tool. Use the tool to the benefit of the field, the design. Not for everything. I can imagine. So when I was a kid, of course, I would never be, even experiencing on those things. No internet, only the books, limited number of books, no mobile phones, only the land phones. You can imagine the time today that I'm experiencing such a quite, rapid change of technology and the resources. But still, what drives behind me is the imagination capabilities which I developed to the involvement of the practical things. not just looking at somebody else's work, whether it is right or wrong, whether it is going to fail or not. I'm going to try it on. This is what you need. Kindly remind me of time. I might be overrunning. Okay, a small challenge for you. Usually in an online class, I would be able to see what you are doing because of the number of participants. But you can take a piece of paper and then just take few minutes, or maybe let's say 30 seconds would be enough. What you see on the screen is an orthographic projection. I would say a first angle projection of an object whose front elevation is given on top, and then the plan is given on the bottom. The two rectangular or square shapes. Don't worry about the size. Don't worry about the size. Now, my first question is, could you identify what this product is? Just say yes or no, few persons, if you can understand. I could easily say yes or no, but the important thing is, if no, I'd say I can't understand what this product is, then you should know why. Because you are all engineers, or you're going to be engineers. You should have some reasons to say no. Or if you say yes, you should say on what basis, on what principles that I imagine the product. This is imagination. This is imagination. Giving or seeing at something to imagine the real world thing. What you see on the screen is a 2D, we call it two-dimensional. But unfortunately, nothing in this world is 2D. Everything is 3D. So it was a kind of a language or techniques that we developed to communicate with other people on a piece of paper. Before that, it was just on the sandbags, no papers even. How do I communicate my ideas, the things that I'm visualizing, of course, in the real 3D object, to someone else using some sketches? So you started with simple sketches, and then it has been developed into a very powerful universal language called engineering drawing. So what you see is only a part of an engineering drawing. It's not complete anyway. It's not complete anyway, but you should be able to understand whether this product is a box shape or maybe some other shapes. Okay, let me open the video inside by. So these are some of the products. You can see if the color changes, that means it's a different product. But it all gives you the same front elevation. Maybe you can count. So these are the front elevations, and you can see the different color and texture. Starting again, the top view, and it also gives you the same thing. Right? Did you count? How many? How many? There were 7 different objects. There were 7 different objects in this particular thing. So means there are 7 objects, different objects, 3D objects, not complicated, simple objects that give you the same front elevation and the same plan. Now I will show you the end elevations. Maybe see whether I'm wrong. So again, in all black color, this is the side view of the first product, side view of the second product, third product, fourth product, fifth product, sixth product, and the seventh product. Right? So in all these objects, it will generate the same front elevation and the same plan. If you still can't visualize, let me show you the isometric views. So this is the first product, the second product, the third product, fourth, 5th, 6th, and the 7th. Now, this is a visualization. Right? If you can imagine some more objects, of course, according to the principles of engineering drawing, right? Because otherwise you can come out with 100 different objects. But what does it mean? You have to be very specific in presenting your information. That is what the engineering drawing means. If you read an article on the newspaper, or if you listen to something, you can come out with different interpretations. That is obvious. That's why this today in all over the world, the lawyers have their jobs, because we interpret different things differently. So ultimately, the judgment will be given by the courts. But in engineering drawing, you don't have courts. It's one unique thing. No matter who is going to prepare this one, no matter who is going to read this one, no matter who is going to interpret this one, no matter who is going to use this one, they should all visualize of the same thing, one unique object. So the problem here, what I have presented is, your presentation is not complete, or it is ambiguous. That's why you could have ended up with 7 different objects. So engineering drawing is such a powerful language that we should learn this one. That is the starting point. Though we have all these very advanced software, still it is a tool. The imagination power is still with you. If you can't imagine, no matter what the software that you are using, you won't be able to do anything. You'll be able to do simple things, but anybody else can do this. Anybody else can do this. There's a saying in the Japanese word, maybe even there's a Sri Lankan version also. If someone can do this or do a job, that means I can also do that one. If nobody can do this, then I should do this. I must do this. That is how the Japanese thinking. How about our way? If anybody can do this, let someone else do it. Why should I do it? Right? And if nobody can do this, how can I do it? So nothing will happen. Nothing will happen. So if you are also in the same line, you are not good for to become a designer. Right? So please understand that. You need to improve your visualization skills. That is where the artist will do. Although we ignore these abilities and the skills, this is where your imagination starts. And then finally, you can convert it to a tangible, excuse me, a product. In very short, this is the design process. You need to start with a concept, identifying the problems, the issues, the requirements, the constraints. Then you develop a concept. It's an idea of how to solve the problem or how to give solution to this problem. You may come out with thousands of ideas. If not, then there is an issue. If not, then there is an issue. So out of these many ideas, then you're going to choose few items, say 1 or 2, based on some criteria. That is again your experience. Because you are thinking ahead right now. I don't know, if I choose one thing, maybe halfway through I have to stop it. There are different techniques used in order to, eliminate many and then select the most suitable one. And then you go for the detailed design. So concept is concept, just an idea, but we don't know the exact size, the shape, the material used, the functions that each and every component will perform, the operating temperature, pressure, the environmental conditions and everything. So we need to design using some scientific, technical ground, what all these things should be exactly. These are called the specifications. specification says if I take something, then it will say what is the length of this one, the width of this one, and the breadth of this one in millimeters. In millimeters. There's a difference actually. As engineers, we are dealing with tangible numbers, numbers that can be converted into a tangible product. For a mathematician or a scientist, so if you say this number 22 by 7, everybody knows that is the number pi. For engineers, what is the use of that one? If you give the length of a box, length of the box as 22 by 7, can you make that box? You cannot make that box because it goes to an indefinite number of decimal places. Engineers need only a finite number of decimal places. As the number of decimal places, if say in millimeters or inches, goes high, then the precision goes high. You need more advanced techniques to manufacture them. Sometimes it is impossible. That is why we call the tangible. So when you are designing the detailed design part, you have to think of the next in line, the manufacturing. Is it possible to manufacture? And the things that you have manufactured, the prototyping, before you put into practice, you test it. See whether it is to the liking of the customer, whether it delivers what we initially thought of. And then how do you going to produce this one? Maybe not in one or two, in large quantities. Sometimes when you scale up the prototype or model, then you have some other issues as well. How do I going to meet all these challenges and then manufacture the product economically so that I can sustain in the long run? So this is basically what the design process is. Whether you do it on a computer or a manual method, it is the same thing. So on the right hand side, we can see the conventional design process. And sometimes we call this the over the wall design. Let's say you are working in a design office and there are partitions, half wall partitions. You are in one of the compartments. So once your part is over, you prepare your technical drawings, the documentation, reports and everything. And somebody will check this one and then put his signature and the date and then hand it over to the other side, over the wall. After that, the communication is over. Then they will study your thing, whatever the problems that they have, they will try to sort it by themselves and then proceed to the next stage. In the worst case, okay, they might refer back to you, but you don't know what is happening. And it takes time. It takes time because it's what you call the serious sequential design, not the concurrent design. Concurrent design is many things happens at the same time. So conventional design give you the idea, but whatever it is, you can see it's a cycle. The design process is a cycle, if not one-way process. And there will be many iterations. That means you need to go back, change something. So for example, the material that you have chosen may not be suitable for something. So then you have to go back and change the material. The moment you change the material, then you have to change your design calculations and maybe the manufacturing processes. So while you repeat the calculations, you might do many mistakes. Who knows? Who is going to check these things? So this conventional design process is taking a lot of time and still not sure about whether you are doing the right thing or not. So this is where the engineering ethics and the disciplines came. You need to follow certain guidelines. You might be a professor, doesn't matter, but you still need to follow the guidelines. Professional ethics, we call it. Right? If you're not going to follow the professional ethics, however knowledgeable you are not suitable for a designer. And then the design thinking. It's not just the thinking, right? The design thinking is slightly different way. I'm not going to talk details about this thing, but it's a teamwork. You need to listen to others, respect the others. Not like what is happening in our country today, that there is only one person who can make all the decisions. Others can only listen to him. But the design world is completely different. Design world is completely different. You should be able to contribute as well. Not that only listen and then contribute. Your contribution may be the worst among the others, but still doesn't matter. For this project, you are the worst, but maybe the next project, you are the best. That attitude, that practice is the most important thing. And it's always a convergent and the divergent process you can see. When you develop concepts, you develop many ideas without thinking of the feasibility of them. And then you select, converge that one into a one or two solutions. And then again you diverge how to achieve those things in practice, the detailed design part. And then you end up with a prototype or something that you can test. So all these things will deliver you the same concept, the same idea. The dotted line, the arrows shows here that it's not the one smooth path. You need to go back many, many times. Sometimes you have to go back to the beginning. In the worst case, you have to drop the idea and then start from the beginning. Start from the beginning. So that is design. If you want to be a successful designer, you need to accept all these things and you need to anticipate all these things that might come in the future. If not, you won't be able to do this one. Like all our students submitting their reports, courseworks, any other things. If the deadline is tomorrow, you start working on this today. The design cannot be done like this. Design cannot, you need to do it in well advance because you cannot see what problems that you're going to face in the future. Whether it is computer aided design or the conventional way, finally you need to produce something like this. We call this one a production drawing. A production drawing. It's not 100% complete, but it gives you many information. Today we are talking about paperless manufacturing, still a bit far with most of the industries today, because the industry needs to gradually catch up the development. Some of the places, of course, you can do this, but still this is what goes to the manufacturing division, let's say your workshop at the end. So you need to include everything here so that the person who is going to produce this one, machine this one, manufacture this one will not email you, call you back, send you SMS, or go into WhatsApp and then put some messages. Nothing. Everything should be included here. So that is the end of the process. And then creativity. Some of the things that I captured from the internet. It's valid even for engineering, right? So this is creativity. The two pictures on the right-hand side will tell you, why do I do this? If I can eat the fruit or this vegetable, why should I do something like this? That is creativity, right? If you have this, that means you have a bright future as a designers. Not only for this, even for these things. How do all these things? No measurements. It's not a technical drawing. How do they manage these proportions with something? If you take, say, wood, for example, if the thing get destroyed, then you can start from the beginning. But this is an existing rock. And how do I do this? So that is creativity. I mean, if you can imagine, your mind will take you to the destination. If you try to, get some assistance from some person, software or book, without having your imagination powers, then you won't be a designer. So this is the conventional design process. It's very simple. You get the requirements, do the detailed designs and implementation. You can say verification and also the maintenance. So this is what I told you over the design, over the whole design. Like for example, it's one after the other. It's happening one after the other. Right? Imagine if you want to do some modification at one place in certain projects. Imagine the worst case, you are building an aircraft. How many components will be there? How many technical drawings would be produced? And if there's a change in one of the drawings, who is going to check whether the modification need to be propagated to other drawings, all drawings or some of the drawings? If you miss one, then what will happen? The manufacturing will not take place in one place, but the assembly will take place in one place. Until you finish and then ready to assemble, then you won't notice whether there are any discrepancies, mismatches. So how do you overcome all these things? Through the design process. And finally, the documentation part. That is the discipline, kind of a discipline that we should have. Conventional design process takes time because you have to carefully analyze these things. You have to keep this in mind. At the end, you can't fail. You can't fail. I'll give you one good example for how critical these design things is. Imagine you have won the best designer competition in the world, not in Sri Lanka, not what the Samira is going to organize you, right? In the world, the best designer concept. You are the best designer, you are labeled as the best designer. And then one day you get an email request or maybe a phone request from a millionaire or let's say a billionaire, and then asking or requesting you to design a personal aircraft for that particular person. Tell me whether you're going to accept the job or not. You are the best designer in this world. If you say no, then there will be an issue. If you say yes, then you have to accept the job and then tell him, okay, I will deliver you the product and everything in 1 year's time. Right. Now everything went smooth. You have designed it, manufactured it, delivered to the person. Now in the next day morning, when you open your email, you see an invitation from the same person. What was in the invitation? What could be like the invitation? He's inviting you to join the first flight of his personal aircraft. It was designed by you, manufactured by you. Everything was handled by you, and you are the best designer in this world. Now he's inviting you to join the first flight. Right? Tell me frankly whether you're going to join or accept the invitation or not. If yes, I don't think hardly any person would accept this one. Most probably you would say, oh, I'm sorry, I have some other work. I have my, some other appointments which I made previously. I'm sorry, I could not make your request and everything like this. You will give 1,000 excuses for not to participate because why? You are not sure about your design. It's flying high. If you are a designer of that nature, there's something wrong. Right? So this is why the design process has very specific guidelines. It can't fail. Whether it is simple tool or an aircraft or a ship, it can't fail. It can, of course, but unexpected things, first time, next time, it should not happen. So likewise, we have very specific guidelines. I hope I'm following the time. Now I'll just go through very quickly. Now these are some of the formulas, not specifically for a particular thing, that we use in our day-to-day design calculations. I need to select the right equation, right parameters to suit the condition. It's like this, for example. Nowadays, it's very common, this antigen text or the, what do you call this, PCR test and everything. You are suffering from some, say for example, a heart patient. And when you go to the doctor, something he is going to do your PCR test, and then the test results say, okay, negative. So you are not infected with the COVID-19 virus, but your symptoms are for something else. Then you come happily. Hey, doctor said I'm negative, nothing to worry about that one. But next day, what happened? You get a severe pain in the heart. You have already had the heart attack and your life is in danger. Right? So that means when you do a test, when you apply an equation and get the result successfully, that does not mean it is safe and it is fulfill the design requirements. You need to choose the right formula, right conditions. Means it is the physics, the nature, which you can't violate. We're trying to, address these physics of the nature by simplifying them into equations. Those equations are not perfect anyway, but at least approximate, so that we can go close to that one and then do some other thing. But you can see it's a very complicated process. And the more complicated thing is, early days, people use a tool like this. I don't know whether you have heard about these things, you know about these things, you have something like this. It's called a slide ruler. All these calculations were done by an instrument like this. And there is an online version, the virtual slide rule, of course. The link I have given in the bottom. You can go there and try your own. Some instructions were also given. All the calculations were done using a slide ruler. Even before me, say a few years back, the university, the examinations, all the undergraduates were using the slide rulers to do the calculations. And then, of course, we go into the different calculations. The first one on the left-hand side is called the adding machine. I still have one physically with me. The adding machine just add numbers. It's a mechanical device, a purely mechanical device. By the way, if you go to the internet, you can see even the first TV was a mechanical device, not electronic device. Right? And then you can see the developments. You can see the developments. And not only that, now we have even more than that. You see, early days drafting office. Could you imagine this? Today, you are very comfortably sit in front of a computer in an air-conditioned room, having large monitors, 2-3 monitors, and then do the drafting work. So this is the situation in early days. You could see the drafting office. The people are working on individual things. We use set of drafting instruments. It doesn't matter whether you use a manual or computer thing, you need to produce these things precisely. Right? Could be a simple shaft or could be an image of this aircraft structure, but you need to make it perfect.
Mr. Janaka, please
Yes.
kindly excuse me. I think it's better because
Time is up, right?
yeah.
Yeah.
If you can wrap this up in
Sure.
2 more minutes.
Sure. Thank you for reminding me. So you can see the computer-aided drafting thing or the design thing. We use only a computer. Computer-aided. Don't hand over everything to computer and then sit in front of the computer and wait until the computer will give you an answer. It won't happen. It will just help you. And we have even more things to check up while you do the computer drafting thing. Not the things that we handle in very early days. You could see the last image about drug design. Can you imagine the time? Right? Why it is getting longer today. We're starting with a mainframe and a desktop with dual or triple monitors, and even with laptops with multiple monitors today is a requirement for the design work. One on the top left-hand side is one of the early screens of AutoCAD, probably AutoCAD 10 or 9. I used to work with this kind of software. That is my starting point. No mouse. No graphics like except what you see on the screen. It's a menu on the right hand side. You use the cursor keys to move up and down. Right? And today, what is on the right hand side, AutoCAD could do. I'm not promoting AutoCAD, but anyway, it's also one of the software tools. And then there are many other software tools available for the computer aided design. They use different technologies. Some are expensive, some are very cheap, some are easy to learn, some are easy to manipulate, right? But they are different. If you want to really see the power of the software, you need to go and check the industry segment who is using this particular software and so on. And then we goes into the analysis work. Something we could not do very early days unless it's a very simple manner. Optimization work. You see one on the bottom left hand corner, right? And even you see something more. This kind of thing would never be possible unless we have all these different software. The manufacturing part. Let me very quickly go through some of the things. I will not go through the details of this thing. Now, can you imagine that you're going to understand these things without the power of 3D modeling? 2D drawing won't help you, right? So these are different techniques we used in 3D modeling, starting from wireframe, the mesh modeling, and then we go into the surface modeling, and then we have finally the 3D modeling. Different tools and the different techniques. Finally, the solid models. So some of the products that I did at my die and mold facilitation center for the industry. One on the right hand side is the latest thing that we are developing, or a power extension code for the local manufacturing sector, which need to be approved by the SLS. And you can see some of the soap molds here, right, which we done by, and then the first on the left hand side, we were handed over the rubber item and taking measurements out of that one and then producing something. It's kind of a challenge. All these things we design at the Diamond Mold Center. You can see the bottle. What I have received was the image of the bottle, what you see on the bottom right hand corner, and then convert it to a 3D model to support a certain capacity as well. And then the last one is the latest product, which is, I promised Samira to talk about this a little bit, not this one, the technology, what the solid edge and other things supports. You know, this is a kind of a sculpture. An artist would do this one on a say piece of clay, for example, and then finally they want to convert this one into a stone carving thing. Not manually, because it takes time. They're going to use the CNC technology. The process is you need to scan this one using a 3D scanner and then convert it to a mesh model. It's called a mesh model. You have only the triangular meshes. I don't have time to go through everything. And then you convert this one into a surface or a solid model. The advantage of solid edge and next and other things, they have this convergent modeling where you can work together with the mesh model and then the BREP models and then converge into a one solid model, which can then be used for manufacturing. And the other thing was AutoCAD was not history based. Then later SolidWorks, Power Engineering and other things were developed to support the feature based, history based modeling, which you need to remember the history. At that time, we thought that was very advantageous. But today, maintaining a history for a long list of features would be difficult. In NX and Solid Edge, you have the synchronous modeling, you don't want to remember the history, but still you have the power of modifying the features or the models in a way that you like, in a very convenient manner. So thank you very much for listening, and I'm extremely sorry for the time that over consuming that usually happens to me. Any questions? Any questions? Can you hear me?
Yes, so we can.
Okay. I thought I'm disconnected.
No, no. Just a note to the participants: if you have any questions, please ask, or maybe raise your hand and send the question in the chat section.
As usual, it seems no questions.
Yeah, I think there are no questions.
Okay then, shall I wind up? I'll be still in the online. I'll wind up my session.
Thank you very much, Mr. Janaka.
Welcome.
Okay. So now it's our time to introduce our next resource person. That will be Mr. Ashen de Silva, the Assistant Manager Technical at Panacea Solutions, an expert in computer-aided design and modeling, and he is here to give us an introduction to Siemens Product Lifecycle Management and Solid Edge. So I kindly invite Mr. Ashen de Silva to take the screen.
Yep, thank you for the introduction. Can someone confirm whether I'm audible and visible?
Yeah, both.
Thanks. Now, thank you, Janaka, sir, for those wonderful insights on design engineering. So let me start, my session with a brief introduction to Panacea. So as Panacea, we've been working as a technology promoter in Sri Lanka, and we've been very closely working with the engineering verticals in the academia as well as the commercial space. And to promote technologies in Sri Lanka, we have partnered up with some global technical giants in form of Siemens PLM, one of our premium partners, and 3D Connection and ANSYS and BricsCAD and MakerBot and so on and so forth. So 3D Connection, again, I'll do a quick introduction of what they are, because we are thinking of covering these things in detail in the upcoming workshops that we are going to have. So 3D Connection can api samanya CAD design එකක් කරනකොට අපි දකුණු අත විතරයි අපි පාවිච්චි කරන්නේ. We work only using our right hand. But with the aid of this device, what we can do is we can bring our left hand also into the design environment, and our navigating, panning, zooming, tilting වගේ right hand එකට ගන්න පුළුවන් ටිකක් tedious options ටික ඔක්කොම අපිට වම් අතට බාර දීලා time saving එකක් ගන්න පුළුවන් අපිට around 30 to 40% of time. So that being said, let us get into the topic of the day without biding much of time. So I will initially rub through a bit of an introduction of Siemens PLM, and then අපි පොඩ්ඩක් peep එකක් දෙමු, or like we'll just sneak and have a look at Siemens Solid Edge and what could Solid Edge offer, and what Solid Edge brings to the table, and how Solid Edge differentiates or like rise above from whatever the rest of the design software is already in the market. So yeah, let us get quickly into the Siemens introduction. And Siemens, of course, started as a garage, a small entity which started in a garage back in Berlin. But today it is at a leading position in electrification, automation, and digitalization. Now they have more than 300,000 employees, and all those fancy stats that you can come up with, they have them covered. So I don't really think that I would need to give you a very thorough introduction of Siemens, because I don't really think that engineering undergraduates, I don't really believe that anyone is here have not heard of Siemens before. So even though I'll just quickly cover what they do. So Siemens PLCs, right? Even more than the software, like what comes to your mind is PLCs. So yes, Siemens does PLCs and under automation wing, and building technologies and drive technologies, energy, healthcare, PET scanners and CT scanners and so on, and mobility, division where they manufacture these bullet trains and of course consumer products, which like not really a thing in Sri Lankan market. I have not really witnessed, but they Siemens manufacture the consumer products like washing machines and refrigerators and so on. So apart from all these things, they come up with their own set of world-class softwares, Siemens PLM division, that is. And that will be our focus of the day. So api I Siemens PLM, so like why Siemens PLM kila kata karnawa na. Now if you see this graph, you will be clearly be able to see this is PLM market by revenue eකට අනුව PLM market එක. So you all can see right how Siemens edging ahead all the competitors in the market. So Siemens PLM ලට එයාලගේ තියෙන portfolio එක consist of Siemens NX, Solid Edge, Technomatics, Team Center, Mentor, and Sim Center. So comes in and second is Dassault with their own product portfolio, including SolidWorks, Katia, Delmia, Innovia, and their 3D experience bunch of softwares. And Autodesk, and the list goes on. So this is actually the fanciest of what insights, so stats that I could throw out. Now this is that Siemens has captured 20% of the digital transformation industry, right? Many digital transformation industry එකේදී තියෙන market share එකෙන් 120ක් Siemens acquire කරගන්න Siemens digital industries වලට හැකියාවක් ලැබිලා තියෙනවා. මේ 120 like it might not sound as a big number when you hear it, right? ඒ කියන්නේ 120ක් කියව ගමන් කාටවත් හිතෙන්නේ නැහැ මේක නිකන් ලොකු number එකක් කියලා. But if you throw out the context, right? So this competition or like the market is flooded with competitors. එතකොට මේ market එකේ ඉන්න අනිත් competitors ගැන මම කතා කරොත් Dassault is there and Microsoft is there. So SAP is there, and Cadence is there. So it's like that, like the market is flooded with competitors, and Siemens has emerged as the single shareholder who has 20%. They can make 20% tamai එක shareholder කෙනෙක්ට තියෙන ලොකුම share එක in this digital transformation industry. So I think the stats speak for themselves, how Siemens has emerged as the leader in PLM segment. So these are some of the customer success stories, or Siemens success stories, which we would like to present to you, right? So here you see the customers who have migrated to Siemens technology from other platforms like SolidWorks and Creo and so on and so forth. So Benji Limited, I think, is a very popular subsidiary of Omega Line Group. So they are a manufacturing company and apparel manufacturing company. So they do this foam molding, and they went with NXCAM solely due to the reverse engineering capabilities of NXCAM. So what happened there was, now they got these solid molds, and they only got one mold, and they had to replicate that mold. So what they did was they scanned it, and the NXCAM software was able to generate the tool path on top of the SLT, or the mesh file that was generated through 3D scanning. So that was revolutionary as far as Sri Lankan market is concerned, and they were able to get a huge time saving by that. So Bodyline is, of course, comes under MAS group. So they were having difficulties. So they were previously with SolidWorks. So they were having difficulties in handling large assemblies. මෙයාලගේ තිබුණා like a ලොකු assembly එකක් open කරාට පස්සේ software එක crash වෙන ලෙඩ, right? So they tried upgrading their hardware systems, but it did not work. Apparently that was a software, that was a glitch or a bug in the software itself, which was not really rectified. So therefore they decided to go on with Solid Edge because of the large handling capabilities, and comes in at third. So they went with NXCAD, this so they were previously with Creo, and of Moratua went with Solid Edge and NX for a technological upgrade, right? They knew what would be the technology or what would the future hold, And Pubudu engineering is one of the other examples which I would like to point out. So they went with solid edge due to the advanced sheet metal capabilities of Siemens softwares. And this is the Siemens PLM presence in Sri Lanka. So this is not the entire list, by the way, right? This is only a small portion of it. We have just filtered up some entities and presented it to you. So even then, like, yes, you can see, like, there are many popular names there, like the MAS Group and the Omega Lines, the Orange Electricals, the Sri Lankan Airlines, Phoenix, and Piramal Glasses, Hemas, DSI, and of course many universities also in there, including University of Moratuwa, and even KDU, Kothalawal Defense University, NSBM Green University, and so on and so forth. So as you can see, Siemens has covered most of the universities in Sri Lanka under the engineering vertical, and many of the famous commercial entities as well in Sri Lanka. So these are actually some of the global migrations, right? In the global context, Dassault systems, Katia and SolidWorks platform, Siemens platforms were switch world class or like global context in design. I mean global context organizations. Daimler, I'm sure you must have heard of it. They manufacture Mercedes Benzes. So they migrated from Dassault systems to Siemens, and Chrysler, of course, I mean car, right? I'm sure that you all know. And Suzuki is the Fiat, the Heidelberg. So all these entities swapped from Dassault systems or other CAD platforms to Siemens in Solid Edge and NX and other PLM solutions Siemens provide. So they, major reason was to convenience that it brings and the productivity that Siemens technology brings to the table. So putting that aside, let us quickly get into the world of CAD, right? Let's have a look at what this has to offer. So the world of CAD, I would like to divide into a couple verticals, right? Initially, I would like to point out there is 2D CAD in the form of AutoCAD, BricsCAD, like there are many 2D solutions there. So we call them as drafting tools, where like you get it, you use it to rather do a draft, you do a 2D drawing of a product or a product, let's say, right? And then there is a 3D CAD, which follows this parametric modeling approach, right? In the form of NX, CATIA, Solid Edge, SolidWorks, and ProE, and so on. So this software, parametric softwares are based on this, parametricity, right? So simply put, it allows you to change the dimension and see the change of the dimension of a solid that you have made live, right? Solid data dimension whenever I change the dimension, dimension change live the dimension changes, right? So that's what basically parametric modeling is, right? And there is this hybrid modeling technology which only Siemens softwares use in NX and Solid Edge. Now this set of softwares rather, they incorporate parametricity as well as these direct based 3D modeling approaches to in their softwares to give the user the edge to create models more effectively, and rather to go ahead and do the edits, the preferred edits more easily, right? So let me get into a bit of detail on that. So Janaka sir, first you can see the history-based modeling approach here, as you can see to the left of your screen. Yeah, left of your screen. So history-based modeling එක කියන්නේ ජනක සර් කිව්වා වගේ අර history එක මත depend වෙන feature free එකක් මත depend වෙන modeling approach එක. So මේකෙදි වාසි සහ අවාසි කියන දෙකම තියෙනවා. So මේකෙදි වාසි ගැන කතා කරොත් අපි මේක dimension driven, of course, right? Dimension driven කියන්නේ අපිට dimension එකක් change කරලා අර මම කිව්වා වගේ dimension එකක් change කරලා අපිට component එකක size එක වෙනස් කරගන්න පුළුවන් live, and it's highly automated. Yes, this is where that parametricity also comes into play. අපිට පුළුවන් මේක හරිම automated. ඒ කියන්නේ අපිට relationships දෙන්න පුළුවන්. උදාහරණයක් හැටියට among two entities, right? අපිට entities දෙකක් අතර relationships දෙන්න පුළුවන්. උදාහරණයක් හැටියට faces දෙකක් තියෙනවා. අපිට මේ faces දෙක parallel වෙන්න ඕන. එතකොට මම එක වෙනස් කරනකොට අනිත් එකත් automatically වෙනස් වෙනවා. මට දෙපාරකට මේ faces දෙක එක මට්ටමකට ගෙනියන්න ඕන නැහැ. මේක සරල උදාහරණයක්, but the point is it is highly automated and of course it's feature based, right? You get you have that on a feature by feature base. So those are the pros of history based modeling, and then there are cons of history based modeling, which is it requires a lot of pre-planning and which is very tedious, right? ඕක ජනක සර් කිව්වා වගේ පොඩි මොඩල් එකකට නම් කමක් නැහැ. මට pre-plan එකක් තියාගන්න පුළුවන්. හරි මේක තමයි මගේ base sketch එක වෙන්නේ. හරි මේක උඩ මම මේක extrude කරනවා. ඊට පස්සේ මේක උඩ මේ මම ආයෙම sketch එකක් ගහනවා. මේක මම extrude cut එකක් දෙනවා. හරි ඊට පස්සේ මම මේක කරනවා කියලා පොඩි මොඩල් එකකට ඕක ප්‍රශ්නයක් නැහැ. We can do some pre-planning. Yes, no worries, right? But when the context gets bigger, right? ඒකෙන් අපිට තියෙන මොඩල් එක අමාරු වෙනකොට, මේ මොඩල් එක ලොකු වෙනකොට ඕක ටිකක් කරදරයි. මම හිතන්නේ ඔයාලත් අත්දකලා ඇති දෙයක් වෙන්න ඕන. ඔයාලා මේ SolidWorks වගේ softwares පාවිච්චි කරලා තියෙනවනේ. අපි මොඩල් එකක් කරලා ඉවර වෙලා මැද්දකදී කොහේ හරි edit එකක් කරන්න ගියාට පස්සේ ඔයාලා හරිව ආසනාවන්තයි අර මොනවාක්වත් exclamation mark, warning marks, feature failures නැතුව ගැලවෙන්න පුළුවන් නම් අපි මොනවා හරි කරලා features 10ක් විතර දැම්මට පස්සේ මැද්දේ ටිකක් edit කරොත් එහෙම, right? ඒක තමයි මේ history based modeling approach එකේ තියෙන අවාසිය. It's very inflexible, right? ඒක flexible නැහැ user ට ඕන විදිහට edits එහෙම කරන්න. It's not flexible and scales poorly on many featured parts, right? And then there is history based modeling වලට අමතරව there is direct modeling method, right? This is more like dealing with a lump of clay, right? It's featureless, right? Api lump of clay again any mati godak එක වගේ වැඩ කරනකොට you can't give features like, you know, everything that you make out of it's the same thing, same body, right? And weak dimension driven editing, yes, dimension එක edit කරනකොට ඒක හරි weak dimensioning තියෙන, and a little design automation you could do when it comes to direct modeling, right? But to the pro side of direct modeling, there is this flexible editing that you get. And because now even it makes sense a lot, right? Again, mati godak එක ඔයාලට edit කරන්න පුළුවන් නැත්නම් මොකද, you just have to අර නිකන් අල්ලලා මේ ටක් ගාලා වෙනස් කරන්න පුළුවන් එක, right? So it lets you directly interact with the model and scales well on many featured parts. And yeah, as I was saying, it gives you the direct interaction between this solid model, right? So මෙතකොට මේ design approaches දෙකේම වාසි තියෙනවා. එයාලටම වෙන් වෙච්ච, එයාලටම සුවිශේෂී වෙච්ච අවාසි තියෙනවා. So Siemens has come up with this patented technology called synchronous technology to bring out the best in all these two modeling approaches to provide the user, right? එතකොට මෙතනදී මේක තමයි history based modeling approach එක follow කරන softwares වලට මම උදාහරණ හැටියට දෙන්නේ. there is Siemens NX, Solid Edge, CATIA, SolidWorks and Autodesk Inventor, right? එතකොට Siemens NX සහ Solid Edge softwares වලත් ඔයාලට ඕන නම් history based approach එක follow කරන්න, that option is there. I will show that to you in a bit. And if you want to follow the synchronous approach, then that is also there in Siemens NX and Solid Edge. Mind you, since this is a patented technology, only Siemens softwares are able to give you the convenience of this synchronous technology, which I will be demonstrating in a little. And I hope Lahiru, your very own colleague, will be demonstrating the feasibility of synchronous technology too. Right, so that part is done. So let me just show you how Siemens controls the CAD/CAM and CAE vendor, right? Yes, now Siemens comes up with all these fancy technologies, fancy design technologies, and so on and so forth. But how are they able to do it, right? So they are able to do this because Siemens own this kernel or the Parasolid kernel, which on top of most of these design softwares are built on. Right? ඒ කියන්නේ මේ Parasolid kernel එක උඩ තමයි SolidWorks, එතකොට MasterCam, Abacus, Delcam, Solid Edge, NX මෙන්න මේ කියන ඔක්කොම softwares ටික develop වෙලා තියෙන්නේ මේ Parasolid kernel එක උඩ. Right? එතකොට ඒකේ තියෙන වාසිය තමයි එතකොට අර ඕන platform එකක තියෙන data හොඳටම read කිරීමේ හැකියාව Siemens softwares වලට තියෙනවා, right? Because it's built on top of their platform, right? So they know how exactly to read Parasolid data and how exactly to work with Parasolid data and how exactly to edge ahead and how exactly to offer something which no other software can offer, right? So that's the beauty of Siemens CAD/CAM and CAE. So that's how Siemens controls rather the CAD/CAM and CAE vendor. And yeah, so let's get into the next generation design with Siemens. So under this, I'm hoping to rub through the solid edge and give you a small demonstration of the solid edge software. So solid edge is let's rather a product. It's not only a mechanical product, as you can see to the right of your screen. It's a product portfolio where you can cater the mechanical, electrical, simulation, manufacturing, publication, and management. So all these aspects of manufacturing you can do under a single product portfolio, right? You can එක platform එකක මේ ඔක්කොම segments manufacturing වල ඔක්කොම segments ඔයාලට cater කරන්න පුළුවන්. So මේක තමයි Siemens ළඟ තියෙන විශේෂත්වය rather, because එයාලා කියන්නේ Siemens does not believe the individual phases of manufacturing. Right? Ultimately, අපි වැඩ කරන්නේ එක product එකකට නම් මේ manufacturing phases should be connected. like අපිට මේකේ වැඩිම වාසිය ගන්න පුළුවන් මේ phases ඔක්කොම එකට interconnect වෙලා තියෙනකොට. මේ phases ඔක්කොගෙම නිරන්තරයෙන්ම intercommunication එකක් තියෙනකොට. එහෙම තියෙනවා නම් අපිට අර last minute surprises අන්තිම වෙලාවේ කියන්නේ අපි හිතමු අපි teams කිහිපයක් වෙන්වෙන්ව වැඩ කරනවා. එක team එකක් එක aspect එකක් බලනවා, තව team එකක් තව aspect එකක් බලනවා, ඊළඟ team එක වෙනම aspect එකක් බලනවා. මේ තුන් දෙනාම එකතු වෙන තැනදී බලනවා හරි අපි මෙතන මෙහෙමනේ ඔයගොල්ලෝ කරලා තින්නේ අපි මෙහෙම කරලා තින්නේ. වගේ those sort of hiccups may come, but this digital twin approach where Siemens has introduced, right, ඒ කියන්නේ අපි product එකේ වගේම product performance වල production වල entire process එක product එකක් concept design එකේ ඉඳලා market එකට යනකම් තියෙන මේ entire process එක digitally map කරලා දෙනවා අපිට මෙහෙම කියලා. අන්න එතකොට අපේ product life cycle එකේ තියෙන අඩලුහුඩුකම්, එතකොට අපේ product එකේ තියෙන වැරදි වෙන්න පුළුවන්, අපේ production mechanism එකේ තියෙන වෙනස්කම් වෙන්න පුළුවන්, අපේ performance engineering ගත්තොත් අපේ performance පැත්තේ තියෙන අඩලුහුඩුකම් වෙන්න පුළුවන්. මේ ඔක්කොම දේවල් ගැන හොඳ digitally map කරලා අපිට අවබෝධයක් දීලා ඉවර වෙලා it lets us to do those changes. So then when we are ultimately when we are අපි ඇත්තටම product එක හදන්න යනකොට we will be fully prepared to whatever comes in our way, and we know for a fact that the product and අපි දන්නවා මේ product එක successful වෙනවා කියලා, because all the insights that we have perfectly mapped digitally, right? So if everything you have done properly, it should be there without any hiccups, right? So this is the solid edge platform or the solid edge portfolio, as I was saying. It allows you to do mechanical design and electrical design, simulation, manufacturing, technical publications, data management, and of course the solid edge portal where you can make your cloud-based collaboration. So all of this comes under one umbrella, you can do this pretty much within the same environment, which allows you to data losses මොනවක්වත් නැතුව single environment එකක මේ දේවල් ඔයාලට කරගන්න පුළුවන්, right? Integrated environment එකක. And not only the synchronous technology, as I was saying, not only the technology is like that, Siemens has generative design as well. මේකෙදි කරන්නේ මම හිතන්නේ ඔයාලා දැනටමත් මේක දන්නවත් ඇති, right? Here අපිට මොකක් හරි component එකක constraint තියාගෙන අපිට නිශ්චිතව තියාගන්න ඕන තැන් ටික තියාගෙන material optimize කරන්න පුළුවන් by giving the strength criteria that we prefer and the constraints of course of the mountings. එතකොට මෙතනත් ඔයාලට පේනවා ඇති මේ පටන් ගන්න component එකේ mounting holes ටික fix ව තියාගෙන ඉවරලා optimize shape එකක් අපිට දීලා තියෙනවා ඒකේ අන්තිමේටම, right? So this is called generative design. And of course, Siemens softwares have the amazing capability to deal with both mesh models, that in scan 3D data, I think Janaka also has mentioned this, and BREP models. They have the ability to combine the mesh models and BREP models and do a design. Ultimately, you can prepare it for additive manufacturing within the same environment. And this is, of course, the solid electrical design software suite, which allows you to do wiring design and harness design, electrical routing, PCB design, and PCB collaboration. More importantly, ECAD and MCAD collaboration. So this is about the solid edge. Very briefly, this is about solid edge design, guys, because it's not a small topic to be covering, in about 25 minutes. So let me just show you. Now I think I have said enough about the software. Right? Let me just show you how the software would actually work. So I have changed my share screen to the software. Can someone confirm whether my software interface is visible?
Yeah, it's visible.
Okay, thank you. right? I'll just quickly go through. I'm going to start a new isometric part here, right? So as I was saying, I'm going to make this model. Just hold on till I show you all the model that I'm going to make, right? So I'm planning on doing this model, this particular model. I think it's visible to all, right? I'm doing this model, and I will use a couple of approaches available to me to do this model, and you can decide which one is the better, right? So yeah, so I have opened up a part file, right? So here is this there is this synchronous කියලා මෙතන තියෙනවා. So මට පරණ පුරුදු විදිහට කාට හරි කියනවා නම් මට synchronous ඕන නැහැ, මට ordered ඕන කියලා, then that person will can simply go to right click this and click on transition to ordered, right? මම දැන් ඉන්නේ ordered mode එකේ. අපිට අපි නිකන් අපි කියන සාමාන්‍ය history based method එකේ. So මම මේකෙදි පෙන්නන්නම් ඔයාලට කොහොමද මම පෙන්නපු model එක create කරන්න කියලා. So I'm going to create it's a very simple model, right? I'm going to press ahead and do a sketch of 100. So my initial goal is to create solid out of this sketch of 100 and 100, right? So I'm going to extrude this. Okay, I'm going to select this chain, and yeah, so I need 100. Yeah, so I have this, right? And I need to make a cut here, right? So I'm going to go ahead with the sketch again, and I'm going to select this plane. And yeah, let's say I'm going to, yeah, so I think I have made a sketch. Yes. And now I'm going to perform an extrude cut here, right? So this is the chain that I'm preferring, right? Okay. And yeah, I'm going to give a dimension of 50 here, right? Okay, right? So now is the interesting part. We are like, we have to do that angular cut, right? Yeah, so I'm going to go ahead with an angular cut, right? මෙතනදී මේක තමයි මෙතන තියෙන අර පොඩි නිකන් අමාරු කියලා ගමු අපි නිකන් පටන් ගන්න කෙනෙක්ට නම් පොඩ්ඩක් නිකන් අමාරුයි කියලා හිතෙන්නේ මෙතන මෙන්න මේ තියෙන angle cut එක ගහන එක. But anyhow, I don't really think it's a very difficult thing. So I'm going to create a new plane, right? A plane by 3 points. So I'm going to click this and this edge, right? To give me a plane. Right, ඊට පස්සේ මම sketch එකක් ගහනවා මේ plane එකේ, right? Yeah, so I'm going to go ahead and create a sketch on that plane, and here. Okay, right? Yeah, so මම sketch එකක් ගහගත්තා, right? Fine, I have finished it. Right, then මම ආයෙම extrude cut එකක් ගහනවා මට ඕන මේ chain එක, right? I'm selecting it and this way, and yeah, right, finish, right? හරි, මට දැන් මගේ අර මම බලාපොරොත්තු වෙච්ච model එක තියෙනවා, right? So this is what I wanted, right? මේකදී ඕනනම් අපි පාටකුත් මොනවා හරි දාලා එමු. Okay, right? So this is what I have actually done, right? ඕන මම මේක හැදුවා. දැන් ඔයාලට බලන්න පුළුවන් මගේ feature tree එකේ කොච්චරක features තියෙනවද. මම මේක ටිකක් ඒ කියන්නේ මම ඔයාලට තාම අදහසක් නැති වෙන්න පුළුවන් මම synchronous පෙන්වෙන්නේ නැති නිසා. So anyhow, I have created my model here, right? So let me just show you how to do this. I'm going to open up another file here, another part here, and now I'm going to use the synchronous method, synchronous approach really rather, to do that, right? So I'm going to go to home, and I'm going to create a box. Lock in this plane here, and yep, I'm going to select 100. I'll go a little slower here, and yeah, bindu. So and on top of that, 100, right? Okay, fine. Now ඔයාලට මතක ඇති කියලා හිතනවා මම අර ඔක්කොම ගහපු අර ඇඳපු sketches කරපු cuts, right, and අර අලුතෙන් දාපු planes ඊට පස්සේ ආපහු දාපු cuts. I hope you'll remember those things, right? Here මෙතනදී I'm simply going to draw a line, right? මම line එකක් විතරයි අඳින්නේ මෙන්න මේ තැන් දෙකට, right? So unlike the other approach, හරි ඔයාලට මතක ඇති මම මෙතන coincide කරලා triangle එකක් අඳින්න උනා මට extrude cut එක දෙන්න. So here I have simply drawn a line, but it has effectively divided my face into two regions. මේ මගේ face එක solid face එක regions දෙකකට කඩලා තියෙනවා where I could perform solid operations, solid modeling operations separately in these two phases. Right? මේක තමයි synchronous technology එකේ තියෙන, it's a beauty of synchronous technology. Right, it allows you to even a simple line, right, lets you divide a solid face to do your operation, right? And as I was saying, right, it lets you directly interact with the model and do your design changes, right? මෙතනදී මම කරේ මම ආයම කරලා පෙන්නන්න මෙන්න මේ region එක click කරපු එක විතරයි, right? click කරලා මට directly model එකත් එක්ක interact කරලා මට අර ආයම features ගානේ extrude කරන්න, cut කරන්න ගිහිල්ලා sketch select කරන්න ඒව කරන්න ඕනේ නැහැ. මට නිකන් simply I have to select and do the dimension. මට push pull කරලා මෙන්න මේ වගේ mouse එකෙන් ඇදලා කරලා push pull method එකෙන් මට වෙනස් කරන්න පුළුවන් dimension එක, right? Okay, so now that cut is there, right? හරි. දැන් හිතන්න ඔය cut එක හරි නෑ කාට හරි කියන්න බුලා හරි ඔය cut එක නම් මේ අරකෙත් ඉතින් එච්චර අමාරුවක් නෑනේ කොහොම හරි කරාරි කියලා, right? Okay, fine, right? Now the interesting part මෙන්න මෙතන තියෙන slope එක, right? This slope. So I'll just quickly show you how easily you can manipulate a face or a solid using synchronous technology. මෙතන මේ තියෙන synchronous arm එක, right? මම ගෙනල්ලා I'm placing it here, right? මම ඒක මෙතන place කරලා ඉවරලා ඒක මෙන්න මේ axis එක වටේ මම වෙනස් කරනවා, right? This is how easily you can manipulate or you can work with solids using the synchronous technology. So here I need to pick the endpoint here. So I'll pick the endpoint here, and again, yeah, okay, fine. Let's do the part painter here and select these two faces, right? So now have a look at the feature tree here. I have only used the box feature and a cutout. One cutout and I have done, right? So this is my what can I say, the ordered approach that I took, and you can see how many parts are there, how many features are there, not parts, like how many features are there, right? So this is the difference that I wanted to point out between the synchronous approach and the ordered approach. Now again I'm saying, right, this is a very simple model, right? It's not a again මේ වගේ model එකක් හරි අර විදිහට කරා මේ විදිහට කරා කියලා ලොකු time saving එකක් ඔයාලට බලා ගන්න බැරි වෙයි. But when it comes to larger context, where හැම company එකක්ම හැම organization එකක්ම productivity එක පස්සේ යනකොට මේ වගේ දෙයකට මේ වගේ පොඩි කාලයක් උනාට save වෙන්නේ ලොකු model එකක් යනකොට the time saving that they are after get, you know, gets bigger, right? Local model manufacturing organizations believe that Siemens technology is the way forward because of this convenience that it brings to the table using the synchronous technology, right? Okay, so I think since my time is running out, I'll just quickly give an intro about the CADEX 2021 competition that we had. So it was in collaboration with Siemens PLM and 3D Connection. Panacea is hosting the biggest CAD competition in Sri Lanka, right? So these are a couple of awesome designs that we have received. This is the winner, of course, Sabanda Taudu from the Sabargama University. And comes in at as the first runner-up emerged Heshan Dharmapala of University of Peradeniya, a very own design by a colleague of yours. And the third place, Gayan Sapumal from CGTTI. And the fourth place, of course, went to Kamit Gayantha of Sabargama University. And the fifth place went to Pathum Thiline of University of Moratuwa. And the merit award winner was Sharoja Fernando for his magnetic train, who represented SLIIT. And of course, the most popular design award went to Lahiru Dilshan of University of Peradeniya, to whom I'm going to invite next to be the next speaker and to give you a much detailed explanation of how synchronous technology can work in your favor. Thank you all for organizing such an event, and we are very glad to be a part of it. Lahiru, over to you. Thank you.
Thank you very much, Mr. Ashen. So as Mr. Ashen Silva said, our next speaker will be Mr. Lahiru Dilshan, a third-year undergraduate from the Department of Manufacturing and Industrial Engineering. And he won the Most Popular Design Award at CADEX 2021. His design is, it was just before on the screen. And so I kindly invite Mr. Lahiru Dilshan to share his experiences with us.
Thanks, Kurani. I will share my screen. Guys, I hope all you can see my screen, right?
Yes, we can see.
Okay, thank you. මම හිතනවා ඔයාලට synchronous technology එක ගැන idea එකක් තියෙනවා කියලා. මම ඔයාලට පෙන්වන්නම් synchronous technology එක use කරලා කොහොමද model එකක් design කරන්න කියන දේ. මම ඔයාලට design කරලා පෙන්වන්නේ මෙන්න මේ L clamp එක. හරි, මම ඔයාලට solid edge open කරගන්නම්. මම මේ විදියට new ගිහිල්ලා මම මේ විදියට new part එකක් ගන්නවා. මම පළවෙනියෙන්ම කරන්නේ මෙන්න මේ center rectangle එකක් අරගෙන මේක තමයි මගේ work space එක. ඒතකොට ඔයාලා මොකක් හරි design කරද්දී ඒතකොට ඔයාලා මේ work space එකේ තමයි design කරන්නේ. මේ වෙලාවේ මට පේන්නේ නැති මෙතන planes ටික hide වෙලා තමයි තියෙන්නේ. ඒතකොට මෙතන අරගෙන මේ ටික දාලා ඔයාලට show කරගන්න පුළුවන්. ඒතකොට මම මෙන්න මේ top plane එකේ තමයි මගේ model එක මම කරන්න යන්නේ. ඒතකොට ඔයාලට මේ plane එකට ගියාට පස්සේ ඔයාලට පේනවා ඇති මෙතන ලොක එකක් පෙන්නනවා. ඒතකොට ඔයාලට F3 එක ක්ලික් කරලා හරි නැත්නම් මෙතන ලොක එකේ ක්ලික් කරලා හරි මේ plane එක fix කරගන්න පුළුවන්. මම මේ විදියට plane එක fix කරගන්නම්. එතකොට මම මේ විදියට මගේ center rectangle එක අඳ ගන්නම්. 80 by 30 dimensions දෙන්න. හරි. ඊට පස්සේ මම මේ විදියට circle එකක් අරගෙන මේ center එක කරගෙන මම මේ විදියට ගන්නම්. ඒක මම dimensions 50 diameters දෙන්න. හරි. මේ විදියට තමයි මම sketch එක ඇඳගන්නේ. ඊට පස්සේ අපිට සාමාන්‍ය solid works වල නම් මේ වගේ sketch එකක් ඇඳගත්තට පස්සේ අපි යන්නේ ඊට පස්සේ extrude එකට. එතකොට extrude function එකට යනවා. එතකොට ඔයාලට මම මේකේ මේ synchronous technology එක ඇතුළේ ආඩ පෙන්නනවා කොහොමද ලේසියෙන්ම කරගන්නේ කියලා. එතකොට මම මේ විදියට මගේ sketch එක මම මේ විදියට select කරගන්නවා. එතකොට ඔයාලට පේනවා ඇති මේ sketch එක select වෙලා පෙන්නනවා. එතකොට මට මේකට කරන්න පුළුවන් ඉන්නේ extrude එකක් විතරයි. එතකොට එයා මෙතන පෙන්නනවා මට මේක extrude එකක් කරන්න පුළුවන් කියලා. මට මේක revolve වගේ එකක් දෙන්න බෑ. එතකොට මට මේ විදියට push and pull method එකෙන් මට මේ විදියට මේක extrude කරගන්න පුළුවන්. මම මේකට දෙන්නම් 34 height එක. හරි. මගේ basic shape එක මම දැන් මෙතන ඇඳගත්තා. ඊට පස්සේ මේක L clamp එකක්. එතකොට L clamp එකේ නම් මට මෙන්න මේ මේකේ planes ටික hide කරගන්න. මට මෙන්න මේ surface එක පොඩ්ඩක් දික් කරගන්න ඕනි. සාමාන්‍ය solid works වල වගේ නම් ඔයාලා එතකොට කෙලින්ම යන්නේ මේක මේ surface එකට ගිහිල්ලා මේක select කරගෙන sketch එකක් ඇඳලා එතනින් extrude කරනවා. එතකොට මේකේ අපිට එහෙම අවශ්‍ය වෙන්නේ නැහැ. push pull method එක හරිම ලේසියෙන් අපිට මේක extrude කරගන්න පුළුවන්. මම මේක මේ plane එක select කරගන්නම්. එතකොට මම මේ විදිහට extrude කරගන්නවා. හරි. මම මේක extrude කරගන්නම් 50. හරි. ඊට පස්සේ මට ඕනි වෙනවා L එක design කරගන්න. මම මේ විදියට line එකක් ගිහිල්ලා මට මෙන්න මේ surface එක මේ විදියට fix කරගෙන මම මේ විදියට මෙතන line එකක් ඇඳ ගන්නවා. හරි. මම මේකට dimensions දෙන්නම් 45. ඊට පස්සේ ඔයාලට පේන ඇති මේ විදිහට regions දෙකක් එනවා. එතකොට මට ඕනි කරන්නේ මෙන්න මේ area එක extrude කරගන්න. මම මේ විදිහට මේක select කළා. මම මේ විදිහට extrude කරගන්නවා. එතකොට ඔයාලට පේන ඇති මෙතන extrude cut එකක් තමයි ආ පෙන්නන්නේ. එතකොට අපිට මේ විදිහට මෙතනට ගිහිල්ලා අපිට add කරගන්න පුළුවන්. එතකොට අපිට extrude කරගන්න පුළුවන්. එතකොට ඔයාලට පේන ඇති මෙතන direction දෙකකට තමයි ආ extrude එක පෙන්නන්නේ. මට ඕනි කරන්නේ මේක extrude එක direction එකකට විතරයි. එතකොට මම මේක මේ විදිහට ගන්නවා. මට මේක සම්පූර්ණ උස 150ක් ඕනි. එතකොට මම මේක 150 minus 34 කියලා දෙනවා. හරි. එතකොට මගේ basic shape එක මම design කරගෙන ඉවරයි. මම දැන් මේකට features ටිකක් add කරනවා. එතකොට මම මෙන්න මේ round feature එකට ගිහිල්ලා මම මෙන්න මේ edges ටික මම දෙනවා 15 වගේ. හරි. මෙන්න මේ edges ටික මම 15 radius එකක් දෙනවා. ඔයාලට පේනවා ඇති. එතකොට මම දැන් මේ edges ටික දුන්නා. හැබැයි ඔයාලට පේනවා ඇති මට මේ edges එකට ගියාම එතකොට solid එක හරහා මට මේ edges පෙන්වනවා. සාමාන්‍ය solid works වල මේ දේ පෙන්වන්නේ නැහැ. එතකොට ඔයාලා object එක rotate කරලා ආයි මේ edges දෙන්න ඕනේ. එතකොට මට මේ විදිහට පහසුවෙන් මේ edges round කරන්න පුළුවන්. මේ edges නොත් මම කරගන්නම්. හරි. ඊට පස්සේ මම මේකට fillet එකක් add කරනවා. මට මෙන්න all fillet කියාට පස්සේ ඔයාලට පේන ඇති මේ විදිහට internal edges ටික එයා automatically පෙන්වනවා. මම මේක 2 mm දෙන්නම්. හරි. ඊට පස්සේ මෙතනින් ගිහිල්ලා all rounds ගිහිල්ලා ඔයාලට පේන එතකොට මේක external edges ටික මේ සේරම ටික පෙන්වනවා. නැත්නම් අපි තනි edges ගිහිල්ලා කරන්න ඕනේ. එතකොට මේ synchronous technology එක ඇතුලේ අපිට පහසුවෙන්ම මේ විදිහට round shape එකක් දෙන්න පුළුවන්. හරි. ඊට පස්සේ මම යන්නේ මෙන්න මේකේ මේ surface එකේ hole එකක් create කරන්න. මට මෙන්න මෙතන hole ගිහිල්ලා මට පුළුවන් මෙන්න මේ surface එක lock කරගෙන මෙන්න මෙතන මේක center එක කරගෙන මේ විදිහට මම hole එක create කරගන්නවා. හරි. ඊට පස්සේ මම යනවා මේක pattern එකක් create කරන්න. මෙතන තියෙනවා pattern. ඔයාලට මේ විදිහට pattern එකක් දෙන්න පුළුවන්. ඔයාලට මෙතන S count එක Y count එක ඔයාලට ඕන විදිහට change කරගන්න පුළුවන්. මම මේ විදිහට එකක් දීලා okay කරනවා. හරි. මගේ දැන් basic shape එක මම design කරලා තියෙන්නේ. එතකොට මට ඕනි කරනවා මෙන්න මෙතන extrude cut එකක් දෙන්න. ඒ වගේ මට මෙතනොත් extrude cut එකක් දෙන්න ඕනේ. හරි. මම මේක sketching අයින් වෙනවා. මම මෙතන top plane එක select කරගන්නවා. මම මේ විදිහට center rectangle එකක් අරගෙන මේක lock කරගන්නවා. lock කරගෙන මෙන්න මේ විදිහට මම rectangle එක අඳ ගන්නවා. circle එකකුත් මම මේ විදිහට අඳ ගන්නවා. ආයිමත් මම මේ විදිහට center rectangle එකක් ගන්නවා. මෙතනත් මට extrude cut එකක් කරගන්න ඕනි. හරි. ඊට පස්සේ මම මේ කරගන්න ඕනේ extrude cut එක. එතකොට ඔයාලට පුළුවන් මේ විදිහට මේ areas ටික select කරගෙන extrude cut එක පහසුවෙන්ම කරගන්න. හරි. මෙන්න මේ විදිහට මට extrude cut එක දෙන්න පුළුවන්. මෙතන මම push pull method එකේ මේ විදිහට කරනවා. එතකොට ඔයාලට පේනවා ඇති මෙතන extrude එකක් තමයි වෙන්නේ. එතකොට මම මේ විදිහට මෙතනින් change කරනවා cut එකක් විදිහට. එතකොට මට මේක whole cut එකක් තමයි දෙන්න ඕනි. එතකොට මම මේ විදිහට direction දෙකටම ගන්නවා. හරි. මේ විදිහට මම extrude cut එක දෙනවා. එතකොට මම ඔයාලට පෙන්නන්නම් මේ synchronous technology එක ඇතුලේ අපිට object එකක් කොච්චර දුරට edit කරගන්න පුළුවන්ද කියන එක. මම මේ විදිහට front plane එක තෝරගන්න. මේ විදිහට මම මේ area එක විතරක් select කරගන්නවා. හරි. ඊට පස්සේ මට මෙන්න මේ circle එකෙන් අල්ලලා මම මේ විදිහට shape එක change කරනවා. මම මෙතන අංශක 5ක් වගේ දෙන්න. හරි. ඔයාලට පේනවා එතකොට object එක සම්පූර්ණයෙන්ම අපිට synchronous method එක යටතේ අපිට change කරන්න පුළුවන්. ඒතකොට සාමාන්‍ය solid work වගේ method එකකදී ඔයාලා මේ වගේ දෙයක් කරන්න යද්දී කරන්න බෑ. එතකොට කරන්න වෙන්නේ අපි object එකට කෙලින්ම කියන්නේ මුලටම ගිහිල්ලා අපි object එක change කරන්න ඕනේ. එතකොට ඔයාලා අත්දැකීම් තියෙනවා නම් අත්දැකීම් ඇති. එතකොට failures එනවා, warnings එනවා. එතකොට ටිකක් කරගන්න අමාරුයි. සාමාන්‍ය ලොකු object එකකට මේ දේ කරන්න කොහොමදවත් අමාරුයි. මොකද ලොකු object එකකදී feature tree එක ගොඩක් ලොකුයි. එතකොට අපිට object එක කරන්න යද්දී සෑහෙන්න ප්‍රශ්න එනවා. හරි මේ ටික තමයි මට සින්ක්‍රොනස් ටෙක්නොලොජි එක ඇතුලේ ඔයාලට කියලා දෙන්න ඕනේ. ඊට පස්සේ මම ඔයාලට පෙන්නන්නම් මගේ CAD model එක CADS competition එකේ. හරි මේක තමයි CAD model එක. මම මේක එතකොට solid modeling වගේම surface modeling use කරලා තියෙනවා. එතකොට ඔයාලා එතකොට competition එකේදී CAD model එක විතරක් මදි. එතකොට අපි මේකට හොඳ look එකක් දෙන්න ඕනි. එතකොට ඒ look එකක් දෙන්න නම් අපිට use කරන්න පුළුවන් එකක් තමයි එක්ක animation එකක් create කරන්න පුළුවන්. නැත්නම් අපිට පුළුවන් rendering images දෙන්න. එතකොට ඔයාලා එතකොට මේ software එක ඇතුලේ ඔයාලට පුළුවන් high quality animation දෙන්න වගේම high quality rendering දෙන්නත්. එතකොට ඔයාලා rendering part එකට ගියාට පස්සේ ඔයාලා keyshot එක හරහා තමයි ඔයාලා render වෙන්නේ. එතකොට ඔයාලා software එක ඔයාලගේ lap එකට install කරද්දී automatically keyshot software එකත් install වෙනවා. එතකොට මම ඔයාලට පෙන්නන්නම් keyshot software එකෙන් මම කරපු rendering part එක. හරි මේ තමයි keyshot එක හරහා මම render කරපු මගේ model එක. එතකොට ඔයාලට මේ වගේ attractive look එකක් දෙන්න පුළුවන්. එතකොට මේ වගේ color combinations ඔයාලට ඔයාලගේ CAD models වලට දෙන්න පුළුවන්. එතකොට දැන් ඉඳන් ඔයාලා ඒ කියන්නේ solid edge software එක ඔයාලගේ lap එකට install කරගන්න. install කරගෙන software එකත් එක්ක familiar වෙන්න ඔයාලට දෙන්න පුළුවන් හොඳම effect එක ඔයාලා competition එකට දෙන්න මම ඔයාලට wish කරනවා. Okay thank you Kulani.
Thank you very much, Lahiru. So our next speaker, he is the country representative of the Philips Corporation. He will be speaking about design in manufacturing. So I kindly invite Mr. Ranidu Danthanarayana to take the screen.
Hello, hi.
Hi.
Can you hear me?
Yeah.
Okay. Good morning, everybody. So first of all, I need thank University of Peradeniya and Panacea organize such kind of nice event, and I need to especially thanks Panacea make happenings in education industry. So yeah, so my name is can you see my screen?
No. We can't see anything.
Okay. What about now?
We can see that you have started sharing. Okay, now.
Okay. So my name is Ranidu Danthanarayana, who representing Ashen Philips product in Sri Lanka. So I'm not take much time. I'm going to talk about few points which required for designing about manufacturing. So I first of all, I just brief about my company. Can you see this my screen?
Yeah, we can see the screen, but it's not on full screen.
Okay. Now?
No.
You can't see it.
Yeah.
What about now?
Yeah, now we can see Philips machine tools.
Yeah, create better ideas.
Okay, now I can see.
Yes. Okay, Philips Machine Tools is a USA-based company. It's a multinational company who is do sales in metal cutting machineries. We have many branches in all over the world. Uh, and just I go through. We have all the solutions for metal cutting, milling, turning, grinding, additive manufacturing, automation, wire cut, wire EDM, and injection molding. These are our products. We have partner in Haas Automation, Hamle, Philips, and many. These you can see this page. There are many partners is joined with us for in industry. In Sri Lanka, we have we have installed more than 100 plus machines in industry. I'm not much involving in education industry, but I'm in my machines are working on in uh, exports on oriented companies and some other job shops. So basically in Sri Lanka, very famous brand is Haas CNC machines. We have installed 100 plus numbers in Sri Lanka. There are many varieties of machines. You can see milling, turning, turn mill, 5-axis, 4-axis, many kind of CNC machines we have installed in industry. And again, Hamle is German brand. They are manufacturing only 5-axis machines. So this is a double column machine made in Taiwan. Just I brief in my about my product range, not takes much time. SHW is universal machine made in German. Sugami sliding head machines made in Japan. GDV is Indian CNC machines. Philips lathe, vertical CNC, vertical turning, surface grinders Kent, multi-grind, a turbine blade grinding, and some kind of machines, and circular grinding, Palmary, EOS 3D printing, powder technology, Markforged 3D printing, and hybrid technology with us for additive manufacturing. So this kind of products we have in our product basket. So I wind up my company briefing, and I just want to brief introduction about design, how think design to practical way for manufacturing. So my presentation, can you see this, my presentation?
Yes, we can see.
Yeah.
But
So
not full screen.
yeah, okay. So there are 3 key product design best practices you should have think. Innovators come from all walks of life and different level of knowledge. Some have a detailed understanding of what it takes to design a product and bring it to market. Others may not be as well versed in the steps. However, all innovators have something in common, even though they are approaching the product design stage from very different levels. They all need to follow 3 product design best practices if they want to succeed. Okay, so what are the three practices, best practices? So first, I take a full outline the product story. When I consider that my first point, so you should have this kind of idea. Know your audience, who is the indeed end users. Understand the ultimate goal of your design. What real world problem is the product should ideally solve. Recognize the barriers associated with getting your product to market. What are the acceptance and failure criteria? Will this product be used in critical systems? For an example, industries like aerospace or medical devices with strict acceptance criteria. So you should have think about that before you start the design. Clearly communicate your timeline. Is the release of this product time sensitive? how much time do you have for potential iterations. So these kind of points you have to think before start design. And when I consider second point, what is that? Design for manufacturability, design for that is the my topic. So there are few kind of things you should have think before designing how we get manufacturing. So there are many techniques, manufacturing techniques. You have to get an idea about manufacturing techniques, and also material properties, and what are the cost effective methods, and what is the market availability for these kind of techniques, materials, and other things. So you should have good idea about manufacturing techniques before start the design. So when I consider that there are many manufacturing techniques, so we can say casting, cutting, drawing, folding, forging, extrusion, machining, punching, shearing, stamping, welding, 3D printing. So in this, then nowadays 3D printing is very famous technology. So everyone is think about this technology. And machining is the most important thing, technology in this industry. So everyone needs to needs to have know-how about machining. So I will go through that machining. So there are many kind of methods for machining, metal machining, metal working machining. So turning, milling, grinding, EDM, drilling, laser cutting, boring. So turning also we can divide several many categories. 2-axis turning, 3-axis turning, 4-axis turning, turn milling, multi-axis turning, sliding head machining, something like that. I have all the technologies with us. We have all the technologies with us. So we have the solutions in our product category. And when we are think about milling, milling we can categorize 3-axis milling, 4-axis milling, 5-axis milling, universal milling, horizontal milling, vertical milling, some kind of methods we have used in industry. So you should have an idea about when we are designing anything, how it will get manufactured. So what kind of method I have to use manufacturing this? What are the materials I have to use manufacturing this? So according to that, it will can make it happen, make it in a practical way. So you should have process also. So some as an example, so grinding and EDM, normally we are use that machines use these techniques for hardened materials. So and also you should have idea about cost, the cycle hour cost and cycle time about these kind of techniques. Then you can make a good design for good design for uh, industry. And again, 3D printing. 3D printing, we have solutions for continuous fiber filament, atomic diffusion additive, and laser metal deposition, and powder technology. So these are the very latest technologies in industry. So you can 3D print as whatever design for, and you can make it happen and see assemblies and see tolerances and working condition. You can make very small scalable designs and practice this. So these nowadays there are many technologies available in the market. So you should have think these technologies, you should have get idea, you should have get knowledge about these techniques before start the design. So third thing, perfect your design with computer modeling. But what Ashen, that Panacea team is talking about. So after that, you can start the modeling from CAD software like Solid Edge. So this is what I want to explain you. Finally, I need to show you some video how conventional design get into additive concept. Please watch this.
Mr. Danthanarayana, Mr. Ranidu,
Hello, yes.
I hope there's no audio, right?
Yeah, there's audio. Can't you?
Okay, yes.
Uh, how can I switch that? Hello?
I think Ranidu, that's okay. I think since we are in the last pass of the video,
Okay.
just I think, yeah, fine.
Yes. Thank you. That Kulani and Panacea team giving me a chance to talk. Yeah.
Thank you very much, Mr. Ranidu. So, as now we have got a great idea about solid edge software and engineering design, it's time for us to unveil an exciting event coming up in your way. So, for the first time in Manufacturing Engineering Association's history, we are going to start a very special event for you all to showcase your talents. So, in order to launch that, I kindly invite Ms. Smritya Somaskandaiyer, the coordinator of the competition, to take the screen. Ms. Smritya.
Yes. Can everyone hear me and see my screen well?
Yeah, we can both hear you and see.
Okay, you don't hear all my background noises, right? I hope not.
No, that's fine.
Okay. So good morning to you all. The Department of Manufacturing and Industrial Engineering and its Manufacturing Engineering Association is organizing MEA CAD competition in collaborations with Siemens Digital Industries. This is a solid edge competition targeted for the undergraduate students at the University of Peradeniya. Our main sponsors for this competition are Siemens Digital Industries, 3D Connection, and Haas. So, here is your chance to bring out all your innovative design ideas. This is a solid edge competition, so all the participants must use the student version of the solid edge to design. I know many of you might not be much familiar with solid edge, but don't worry, we will provide you with plenty of resources and tutorials for you to practice. There will also be a solid edge workshop held on 6th of July to help you get started with the software. And also you will have mentors like one of the few CADX 2021 winners to guide you through. And after this webinar, all the participants who have joined today will be provided with links and all the resources. So why wait? Let's get started today onwards. So who can compete in this competition? So this competition is targeted only for the undergraduate students at the University of Peradeniya, and it is a great opportunity for you all to show your design talents. So if you are planning on competing, please register before 3rd of July, and the registered participants will receive the task and theme of the competition on 4th of July. The participants will also receive a set of guidelines to follow in the competition. So in this competition, all the competitors will go through two phases. And in the first phase, the participants will be asked to design and the best few designs will be selected to go through the second phase, where the competitors will be asked to modify their initial design. Now to the most exciting part, prizes. So the first place will receive 3D Connections wireless space mouse. Second place will receive 15,000 rupees. Third place will receive 7,500 rupees. And on top of it, like all the outstanding designs will receive merit certificates. All the outstanding designs will also be showcased in all the social medias and the DMIE website. So all the information I shared with you today will be emailed to all the participants. That includes all the links to all the resources and tutorials. And my email and my contact number will also be shared to all of you. So if you have any questions, please do not hesitate to contact me. Thank you.
Thank you very much. Thank you very much, Ms. Mritya. So I think this competition will be a great opportunity for all of us to participate and show our talents. So our next speaker will be Mr. Heshan Dharmapala, a third-year undergraduate at the Department of Manufacturing and Industrial Engineering, who also took part in a competition and won first runner-up. The competition was CADEX 2021, organized by Panacea Solutions. So I kindly invite Mr. Heshan Dharmapala to share his success story.
Hello, can you hear me?
Yeah, we can hear you.
Okay. I think you can see my screen.
Yeah, we can see, but not on full screen.
Okay. I'm Heshan from the Manufacturing and Industrial Engineering Department. First, I will share my experience about the CADEX 2021 competition. I am the first runner-up of this competition. Islam කිව්වොත් මේ competition එක is the biggest CAD competition in Sri Lanka. මොකද ලංකාවේ හැම campus එකකම වගේ ඉන්න 3D designers ලා undergraduates ලා බොහෝ දෙනෙක් මේකට සහභාගී වෙනවා. ඒ වගේම අපේ competition එක ගත්තොත් සමහර post graduate අය කීප දෙනෙක් සහභාගී වෙලා හිටියා. So there were more than 400 plus competitors. So ඕගොල්ලෝ ඒ කියන්නේ මොකක් හරි place එකකට යන්න මේ target එකක් තියෙනවා නම් ලොකු තරගයක් දෙන්න වෙනවා. ඒකෙදි. එතකොට අපි ඒකේදී design එක කරේ solid edge use කරලා ඕගොල්ලෝ දකින්න ඇති software එක ගැන. එතකොට මම software එක ගැන මුලින් කියලා ඉන්න. මේ software එකේ තියෙන ලොකු advantage එකක් තමයි ඒක මේ දැන් අපි දන්නවනේ SolidWorks වගේනේ අපි use කරන්නේ. දැන් මමත් ඇත්තටම ගොඩක් මේ SolidWorks තමයි use කරලා තියෙන්නේ. හැබැයි ඒකේ නැති මේ synchronous technology කියන එක solid edge ලා දීලා තියෙනවා. ඒකේ අර ගොඩක් අපිට මේ user friendly interface එකක් දෙනවා. ඒ වගේම මේ අපේ design එක ගොඩක් quick අපිට කරගන්න quickly අපිට කරගන්න පුළුවන්. මොකද මේ time එක ගොඩක් save කරගන්න පුළුවන් ඒකේ. ඊළඟට අපි මම කතා කරන්න මගේ design එක ගැන. මේ තියන්නේ මගේ design එක අපේ team එක උනේ future transportation. ඒ කියන්නේ future එකේ මොකක් හරි transportation විදිහට මොකක් හරි improvement කරන්න එන්න ඕනේ. එතකොට මේ මම කරපු design එක මේකට කියන්නේ මම කියන්නේ ඒකට sea bottom explorer කියලා තමයි කියන්නේ. මම explain කරන්න මොකක්ද කියන්නේ. Can you see my design? Can you see my design?
Yeah, we can see.
මේ sea bottom explorer කියන එකේ දැන් මම හිතපු දේ තමයි දැන් අපි තියෙන දෙයක් හදනවට වඩා මම හිතුවේ අලුතෙන් මොකක් හරි මේ දෙයක් අලුත් දෙයක් කරන්න කියලා තමයි මේ මගේ ටාගට් එක. ඒකට මම දැකපු දෙයක් තමයි දැන් underwater vehicle දැනට ලෝකේ තියෙනනේ ඕන තරම්. ඒ කියන්නේ ඔය මේ autonomous ඒවාක් තියෙනවා නැත්නම් manual යන ඒවාක් තියෙනවා. හැබැයි ඒ එකකවත් මම දැක්කේ නැහැ. ඒ කියන්නේ දැන් හැම එකම දැන් float වෙලා යන්නේ. ඒ කියන්නේ මොකක් හරි ship එකකින් හරි boat එකකින් හරි ගිහිල්ලා අපි මේ sea එකේ surface එක අතර ඊට පස්සේ පල්ලෙහාට dive කරලා වගේ තමයි යන්නේ. එතකොට මේ මට ඕන වෙච්ච දේ තමයි දැන් අපි මුහුදේ sea floor එක කියන්නේ මුහුද පතුල දිගේ යන්න පුළුවන් විදිහට වාහනයක් හදන්න හැදුවා නම් කියන අනාගතයට කියන්නේ එහෙම දෙයක් තිබ්බා නම් කියන එක තමයි මගේ ඔළුවට ආවේ. එතකොට මට ඕනුනේ එහෙම දෙයක් හදන්න. එතකොට දැන් ඒකෙදි වෙන්න ඕනි දේවල් සයන්ටිෆික් විදිහට හිතලා තමයි මම මේ ඩිසයින් එක කරේ. මේ ඩිසයින් එක ගැන විස්තර කරොත් මේකේ ප්‍රධාන කොටස් දෙකක් තියෙනවා. මේ අපර් පාර්ට් එකයි ලෝවර් පාර්ට් එකයි. ලෝවර් පාර්ට් එක ගත්තොත් එහෙම ඔයගොල්ලන්ට පේනවා ඇති මේ චේන් එකක් තමයි තියෙන්නේ. එතකොට අපි දන්නවා දැන් මුහුද ඇතුලේ යද්දි මේ අපිට තියෙන්නේ බෝයන්සි ෆෝස් එක කියන්නේ උඩුකු තෙරපුම් බලය. එතකොට දැන් මේ මෙතෙන්ට රෝද හයි කළා නම් වෙන්නේ මොකද්ද? ලොකු පරිමාවක් කියලා. ඒ කියන්නේ අපිට මේ පරිමාව වැඩි වෙද්දි මේක ස්ටේබල් නැහැ. මේක ෆ්ලෝට් වෙන්න ඕන. එතකොට ඒක මග හරවන්න ඕන හින්දා එක හේතුවක් මම මේ චේන් යූස් කරපු එක. ඊළඟට අපි දන්නවා දැන් මේ යුද්ධ ටැංකියක උනත් මේ චේන් එකක් නැති. මොකද මේ ඕනි සර්ෆේස් එකක යන්න පුළුවන්. දැන් මුහුද සර්ෆේස් එක උනත් අපිට කියන්න බෑනේ කොයි වගේ දේද කියලා මුහුදේ බොටම් එක. එතකොට මම ඒක අනුව තමයි මේ චේන් එක දාලා තියෙන්නේ. එතකොට ගොඩක් ලොකු සර්ෆේස් එකක් ටච් වෙනවා පොළවේ ඒත් එක්ක අපිට අර ස්ටේබල් වෙලා යන්න පුළුවන් පතුල දිගේ. ඒ වගේම මෙතන ඔයගොල්ලන්ට පේනවා ඇති මේ රොබෝටික් ආම් දෙකක් දාලා තියෙනවා. මේකේ පර්පස් එක උනේ එකක් තමයි දැන් අපි සමහර විට යනවා වෙන්න පුළුවන් මොකක් හරි මේ ඒ කියන්නේ එක්ස්ප්ලෝර් කරන්න යනවා වෙන්න. එතකොට අපිට හිතමු දැන් ෆී එකක් කියන්නේ. ඒකේ අපිට මොකක් හරි සාම්පල් එකක් කලෙක්ට් කරන් එන්න ඕන වුණොත් එහෙම අපිට මේ රොබෝ ආම් එක පාවිච්චි කරලා ඒක කලෙක්ට් කරගන්න පුළුවන් සාම්පල් එක. එතකොට ඊළඟ එක තමයි දැන් අපි මුහුද යනකොට අපිට මොකක් හරි ඔබ්ස්ටැකල් එකක් තිබ්බ කියමුකෝ අපේ පාත් එකේ. ඒක මේ අපිට මේක මේ ක්ලියර් කරගන්න බෑ. එතකොට මේකෙන් අපිට පුළුවන් ඒ තියෙන ඔබ්ස්ටැකල් එක අල්ලලා ඒ කියන්නේ අයින් කරලා අපේ පාත් එක ක්ලියර් කරගන්න. එකක්. ඊළඟට ඕගොල්ලන්ට පේන ඇති මේ පොළ පාටට වගේ තියෙන ලයිට්ස් මම ඩිසයින් කරලා තියෙන්නේ. මොකද මුහුදේ බොටම් එකේදී අපිට ඉරේලිය එහෙම ලොකුවට ලැබෙන්නේ නැහැ නේ. එතකොට ඒකට තමයි මේ ලයිට්ස් දාලා තියෙන්නේ. ඊළඟට ගත්තොත් මේ ඇන්ටෙනා එක. ඒ කියන්නේ අපි දැන් මොකක් හරි අපේ ෂිප් එකක් එක්ක හරි කමියුනිකේට් කරනවා නම් ඒ සිග්නල්ස් ට්‍රාන්ස්ෆර් වෙන්න බෑ. ඒකට තමයි මම මේක සෙට් කරලා තියෙන්නේ. ඊළඟට ගත්තොත් පෙන්නන්නම් දැන් අපි මේක මේ හිතමුකෝ සී බොටම් එකේ යනවා කියලා. එතකොට දැන් සමහර වෙලාවට අපිට මේකේ weight එක මදි. ඒ කියන්නේ අපේ buoyancy force එක වැඩි වුණොත් එහෙම අපිට දැන් මේ ඔබ්ජෙක්ට් එකේ මේ පරිමාව අඩු කරන්න විදිහක් නැහැ නේ. එතකොට දැන් අපිට පුළුවන් එකම දේ තමයි මේක බල වැඩි කරන්න. ඒ ස්ටේබල් වෙලා ඉන්න නම් මෙතන අපි මේකේ මේ බල වැඩි කරගන්න බෑ. ඒ වෙනුවෙන් මම ඩිසයින් කරපු දේ තමයි මෙතන මේ පල්ලෙහා දැම්ම ටැංකිය. මේ ලොකේට් කරලා තියෙන පේන ඇති වලුන්ට. මේක මම කරලා තියන්නේ දැන් අපි කොහෙදී හරි අපේ මේ weight එක මදි වුණොත්, ඒ කියන්නේ ෆ්ලෝට් වෙන්න වගේ බලනවා. අපිට පුළුවන් මේ ටැංක් එකෙන් වතුර පුදවන්න. ඒ කියන්නේ මුහුද ඇතුලේ. එතකොට අපිට ස්ටේබල් වෙලා ඉන්න chance එකක් තියෙනවා. මොකද අපි බල වැඩි වෙන හින්දා. අනිත් දේ තමයි දැන් මේ ටැංක් එක අපි හිතමු මේ වගේ මේ සයිඩ් එකකට වෙන්න අපි ලොකේට් කරලා කියලා මේ හරි මේ දෙපැත්තේ හරි. එතකොට දැන් මුහුදදී අපි වතුර ගන්නකොට ඒකට අපි දන්නවනේ අර එක පැත්තකට බල වැඩි වෙනවනේ. එතකොට මේකේ පොඩි මොමන්ට් එකක් ඇති වෙලා මේක පෙල්ලෙන්න බලන්න. එතකොට අපි හරි ඒ කියන්නේ හරි විදිහට ගත්තොත් එහෙනම් අනිවාර්යෙන් ඒක මේකේ මේ ග්‍රැවිටි සෙන්ටර් එක ඒ කෙලින් තමයි තියෙන්න ඕනේ. මොකද මේ ස්ටේබල් වෙන්න. ඊළඟට මේ රඩර් එකක් යූස් කරලා තියෙනවා මේක මේ හදවනකොට අපිට මොකක් හරි උදව්වක් ගන්න ඕන වුණොත් කියලා. ඊළඟට දැන් මම කියවනේ මේක මේ එක්ස්ප්ලෝර් කරන්න යනවා කියලා. එතකොට අපිට දැන් මොකක් හරි crew membersලා අරන් යන්න ඕනේ වුණොත් ඒගොල්ලොන්ට දැන් එළියට එන්න ඕන වුණා කියමු. මොකක් හරි අපි හිතමු මොකක් හරි ඩයිව් කරන්න දෙතුන් දෙනෙක්ට එළියට එන්න ඕන වුණා කියලා. ඒ වගේ අවස්ථාවක මම හිතපු දෙයක් තමයි දැන් වාහනයක් වගේ දොරක් ඇදලා එළියට එන්න බෑනේ. මොකද මේ මුහුද ඇතුළේදී ඒතර අපේ වතුර පිරෙනවා මේක ඇතුළේ. ඒකට මම කරපු දේ තමයි මම දැම්මා මේ සේෆ්ටි රූම් කියලා. ඒ කියන්නේ ඉස්සල්ලාම දැන් ඒගොල්ලෝ මෙන්න මේ සේෆ්ටි රූම් එකට එන්න ඕනේ. මෙන්න මේ ඩෝර් එක ඕපන් කරලා. ඊට පස්සේ මේක වහන්න. ඊට පස්සේ මෙන්න මේ රූම් එකේදී තමයි දොර ඇදලා ඒගොල්ලෝ එළියට එන්නේ. එතකොට දැන් ඇවිල්ලා ඒගොල්ලෝ මේකත් වහනවා. එතකොට දැන් අපි දන්නවනේ මේ රූම් එකේ මේ වතුර පිරෙනවනේ. ඒ ටික අපිට අයින් කරන්න පුළුවන් මේ තියෙන ස්ලොට් එකේ. මෙන්න මේ ස්ලොට් එක දිගේ ඉතුරු වෙන වතුර ටික අරන් ගිහිල්ලා මෙන්න මෙතනින් මේ තැන් වලින් අපි එළියට දානවා. ඊට පස්සේ ඒකට ඒ ප්‍රශ්නේ හරි. ඊළඟට ගත්තොත් කෙනෙක්ට හිතෙන්න පුළුවන් දැන් මේක කොච්චර කවද්ද මේක ගිහිල්ලා මේ මුහුද ඇතුලේ හිර වුණොත් මොකද? එතකොට ඉන්න අය මුහුදු පතුලේ ඉන්න වෙනවා. එතකොට එළියට එන්න විදිහකුත් නැහැ. මොකද මේ උඩට ඩයිව් කරන් ඉන්නත් බෑනේ ලොකු උසකට. ඒ සේෆ්ටි එක ගැන හිතලා මම කරපු දෙයක් තමයි දැන් මෙන්න මේ අපර් පාර්ට් එක මෙන්න මෙතනින් ගලවන්න පුළුවන්. ඒ කියන්නේ හින්ජ් එක ගලවන්න පුළුවන්. ඊට පස්සේ මෙන්න මෙතන මම දැම්ම සේෆ්ටි බැලූන්. පේනවද ඔයගොල්ලන්ට? මෙන්න මේ සේෆ්ටි බැලූන් එකේ අපි කරන්නේ මෙන්න මේක මෙතනින් ගලවලා ෆික්ස් එක අයින් කරලා ඊට පස්සේ මේ බැලූන් එක යවනවා. ඒවට දැන් මේක මොකද යායකකින් මේක පුඹනවා. එතකොට වෙන්නේ අපිට මේ අපර් පාර්ට් එක කියන්නේ ක්‍රූ එකේ කට්ටිය ඉන්න කොටස අපිට මේ මුහුදේ සර්ෆේස් එක දක්වා අපිට අරගෙන යන්න පුළුවන් කොහොමද? ඒ කියන්නේ මේ ඇතුළින් අයගේ ජීවිත කොහොමද බේර ගන්න පුළුවන් ඒකනේ. ඒක තමයි මම මේ සේෆ්ටි එක පැත්තෙන් කරේ. එතකොට අපි ගත්තොත් මේ ටර්න් කරන්න පුළුවන් මේක මේ අපර් පාර්ට් එක. ඊට පස්සේ ගත්තොත් දැන් මේ ඩිසයින් එක ගැන කතා කරොත් මේ මම solid edge වලින් හදලා තියෙන්නේ. මම ඇත්තටම මේ solid edge එහෙම ෆැමිලියර් උන්නේ කලින් නම් මම දන්නේ නැහැ එහෙම software එකක් ගැන. මේ CADX වලටම තමයි මම ඒක use කරේ. එතකොට මේ මට කියන්න ඕනේ දැන් සති දෙකක් වගේ ඇතුළත තමයි අපිට කම්පිටිෂන් එකට වෙලා ස්ටියන් දුන්නේ. එතකොට මම software එක download කළා. ඒ කියන්නේ පොඩි කාලයක් ඇතුළත මේ වගේ ලොකු ඩිසයින් එකක් ඇඳ ගන්න පුළුවන් වුණානේ. ඒ කියන්නේ ඇත්තටම මේ solid edge එකේ user friendly ගතියක් තිබ්බා ඇත්තටම. නැත්තම් මොකද මේ වගේ complex design එකක් ඇඳ ගන්න බෑ අපිට. ඒ කියන්නේ පොඩි කාලෙකදී මොකද නොදන්න software එකක් මේ අලුතෙන් user කෙනෙක්ට ඒ කියන්නේ මගේ experience එක විදිහට මම කියන්නේ. ඒකින්ද මේ ඕගොල්ලන්ටත් මම recommend කරනවා මේක ඉගෙන ගන්න. Thank you.
Thank you very much, Ashen. So, Mr. Ashen was our last speaker for the day. So, as we have already come to the end of this session, I hope that you all got a good understanding about the Solid Edge software, and then that you feel your morning was well utilized. So, I have a small announcement to make before concluding this session. There's a Facebook group created for all those who are interested in Solid Edge software, and the group is called Solid Edge Tips and Tricks. So the link for that Facebook group is put up on the chat section. I think you can see it. So if you are interested in getting to know about Solid Edge, you can join that group. So to conclude today's session, I'm going to invite Mr. Ashen Jayatilaka, the Joint Secretary of Manufacturing Engineering Association, to thank everyone.
Am I loud and clear?
Yeah.
Yes, thank you, Kulani, and good morning, everyone. As we already reached the end of our session, I believe everyone obtained good knowledge on engineering design. On the behalf of MEA, I would like to thank Mr. Janaka Mangala for joining with us today to provide us vast knowledge on engineering design and engineering design evaluation. Again, thank you, sir, very much. I also extend my thanks to Mr. Ashen Silva for giving a great introduction to Siemens, TLM, and Solid Edge. Also, I express my gratitude to Mr. Samir Madpat and Mr. Asita Punchiheva and the Panacea team for organize and coordinate this wonderful event. I also wish to express my gratitude to Mr. Ranidu Danthanarayana, who not only sponsor us but also reserved his time to teach us on design in manufacturing. Furthermore, I'm grateful to Mr. Ashen Dharmapala and Mr. Lahiru Dilshan for gracing your improvement work, sharing your achievement with us. Finally, I should not forget the all participants who attend this morning. Without you, this event would not have been a success. Now it's time to conclude this workshop. Hoping you will meet again in our future event. Have a nice day. Stay safe.
Thank you, Ashen. So I wish everybody to have a good day.
Thanks all.
Thank you.
Thank you very much.
Thank you very much.